Welcome to you all in my YouTube channel Experience Mathematics. Today I am with the topics factorization, second part of the factorization topics. Before starting, I want you to make sure that you subscribe my channel and press bell icon so that I will be encouraged to make similar type of videos. So without delay, I'll start my today's topics. Factorize. We have one problem of factorization here. 1 minus m minus n plus mn. So for this factorization, we will take common from this minus n plus mn. So from this and this plus mn we have minus n common. So how it happens, I will show it to you. Here this equals to, we have 1 minus m, and here we have minus n, and this plus means it is minus times minus m times n. So from this here we have this minus and this outside minus, this is common, that is minus n is common, n is here and also n is here, so that is common. We have this minus, here is nothing means 1, and this minus is common. So here after you take n common, n1 is here, and after you have taken out minus, this minus will be here, and n has already been taken out, so m is here. In this way we get this expression, and now this 1 minus m, and here is also 1 minus m, that is common, and remaining expression is 1 minus n, remaining factor is 1 minus n. In this way we can factorize this expression. And at last we have so 1 minus m, this also minus m we can write it first plus 1 and taking out minus common, and from this also we can write minus n plus 1 and taking out minus common from this, and from this will be cancelled, and so we get m minus 1 times n minus 1. Okay, so in this also like before, like this way we can take out common. How it will be, you can see here. So here from this step we can write like this way. We can write minus m plus 1, and in this also minus n plus 1, and like before this minus 1 will be common, so inside there will be m minus 1. From this minus 1 will be common, inside there will be n minus 1. Minus from this and minus from this will be plus, so we have m minus 1 times n minus 1. In this way we can easily factorize such type of expression. So minus 1 and minus 1 common from 1 minus m, and 1 minus n becomes plus 1. I have written here. So now we have another problem of factorization. AB minus BC, BC minus AB. This is also of the same kind. So here this first expression I have written as it is plus BC. Here we can write this minus AB at first, and after that BC has no sign, means plus sign, so plus BC we have written here, and AB minus BC. So from this minus is common, minus times plus it will be minus, BC is here, and this minus times this plus will be here minus, okay, or this minus times this plus is minus, and BC here, and here AB minus BC and AB minus BC, and from this two B is common, so after you take out B common, there will be A minus C left, and from this two B is common, so there will be A minus C left, and now this B and this B can be multiplied, and we will get B square. A minus C times A minus C is A minus C whole square. Okay, so in this way if we can make factor same in this and this, then taking out common, we can easily factorize such type of expressions. Now factorization of trinomial. Trinomial means the algebraic expression having 3 terms. This tri meaning is 3, so trinomial means the algebraic expression having 3 terms. So here is one example. Fill in the gap to make each of the following expression a perfect square. Okay, to make the expression perfect square, it must either be a trinomial to be perfect square, either it must be a plus b whole square form, or it must be a minus b whole square form. So here this x square in the middle plus, and at last this is also perfect square term. The 16 means we can write plus 4 square. So if a square plus and a gap there and at last plus b square type, then we can change this into a square plus 2ab plus b square. And if we can change into a square plus 2ab plus b square, then we can write that a plus b whole square, and so it becomes perfect square. So how to change it into a square plus 2ab plus b square form? Look at here. Here this is a square, this 16 is 4 square. Now this became a square, this became b square. Now to make perfect square we need 2ab here. 2a, in place of a we have x, in place of b we have 4. Now it became just like a square plus 2ab plus b square. So we have formula is a square plus 2a b plus b square equals to a plus b square. Okay, so if we can make a square plus 2ab plus b square, then we can write a plus b square. This will be perfect square. And so here in place of a we have x, in place of b we have 4. So 2ab term is needed to make perfect square, and so 2a means here x, and in place of b we have 4. Okay, so we have to fill up 8x in the gap to make the given expression perfect square. Similarly, 8x should be inserted in the blank to make a perfect square expression. And now x square minus plus 4. So this one is a square minus 2ab plus b square type of expression. Okay, here 2ab should be inserted. So 2 times a means x, b means here 2. Okay, 4 means we can write 2 square because 2 times 2 is 4. And now here this 4x should be inserted so that the expression becomes a perfect square. 4x should be inserted in the blank to make a perfect square. So here the formula is a square. Here if minus a square minus 2ab plus b square will be a minus b whole square. Okay, so using that formula you can make it perfect square. Your formula used is, here the formula used is a square minus 2a b plus b square equals to a plus b whole square. Sorry, a not a plus b, a minus b whole square. This is the formula for a square minus 2ab plus b square is a minus b whole square. So a minus b whole square is the perfect square. To make it, we have to insert here 4x and it becomes perfect square. Okay, after we insert 4x here, it becomes perfect square. So now we have to factorize this expression. This is the trinomial, and when there is trinomial, we first of all observe that whether the first term is perfect square or not. Here x square is the perfect square and last term is perfect square or not. We should observe first and last term. First term is perfect square, last term 25 is also perfect square, because okay, so here while factorizing the expression containing three terms are trinomials. To factorize the trinomials, we should first of all observe that whether the first term is perfect square and the third term is perfect square or not. If first term and third term are perfect square, there is the possibility that it may be of the type a square plus 2ab plus b square. Okay, it can be of the a square plus 2ab plus b square type. So like before, we can write a square plus 2ab plus b square equal to a plus b whole square. Then it is factorized easily. Okay, so here first term is a square perfect square, and then second term we can express in the form of 2ab. If we can express in the form of 2ab, then if the last term is perfect square b square, then if this given expression can be changed into a square plus 2ab plus b square form, then we can write this as a plus b whole square. We can write this in the form of a plus b whole square. So now here look at here, this is x square and this is 5 square. Now middle one 2 times, in place of a we have x, in place of b we have 5, so we can make 2ab, and here 2 times x times 5 is 10, so the middle term, from middle term we can make 2ab. Okay, so here in place of a x, in place of b we have 5, and so 2ab means 2 times x times 5. So this 10x we could express in terms of, in the form of 2ab. So you can write in place of a x, in place of b 5, so it becomes x plus 5 square. Okay, and in this way this x plus 5 square or x plus 5 times x plus 5 is the this x plus 5 times x plus 5 are the required factors of this given expression. Okay, so here in this we have minus here, so this a square perfect square, this 144, it can be written 12 square, it is also perfect square. Okay, so whether it is perfect square or not, you can see by using calculator or by factorization. 144 square root, if you find out exact value, you find out that it is perfect square. Okay, and 144 square root, if you find out using calculator, you will get 12, so it is perfect square. Okay, so first and last is perfect square, and we will see whether it can be expressed in the form of 2ab or not. Okay, if you can express in the form of 2ab, then we can use a square minus 2ab plus b square. Okay, and our formula for a square minus 2ab plus b square is, our formula for a square minus 2ab plus b square equals to, it is a minus b and its square. Okay, so our first and last term is perfect square, so this is a square, this last one is b square. And now a square minus 2, in place of a we have a, in place of b we have 12 plus b square, 141 is 12 square. So now here using this formula, in place of a we can write a, in place of b we have 12, so we can write 12, so it becomes a minus 12 square. So a minus 12 square or a minus 12 times a minus 12, that are the required factors of this expression. Now factorization of trinomials perfect square type, this I have already explained. Okay, a plus b whole square, a square plus 2ab plus b square, a minus b whole square, a square minus 2ab plus b square. While factorizing the expression of the type a square plus 2ab plus b square, we have a square plus 2ab plus b square equals to a square plus ab plus b square, and from this 2 A is common, a plus b. From this 2, b is common, a plus b we get. So a plus b times a plus b or a plus b whole square. Okay, this thing I have already explained. Similarly, we have a square minus 2ab plus b square equal to, we can write a minus b whole square. In the same way, this minus 2ab equals to, we can write minus ab and minus ab. So this equals to, we can write a minus b whole square. Hence, by using the formula, we can factorize the perfect square type of trinomials. So I have given some questions in which you have to use a square plus 2ab plus b square equals to a plus b whole square, and a square minus 2ab plus b square equals to a minus b whole square. So using the same idea, these questions can be done here. In this, from this all we can take out common. In this also, after you can make a square minus 2ab plus b square, then you can take out common and you can factorize. Okay, so this also can be done in the similar way. Okay, changing into a square minus 2ab plus b square. And as I have already said that after factorization, if you multiply the factors, then you must get the question, so that whether your answer is correct or not, you can check it yourself. Even in examination, after finishing all questions, if you have enough time, how much answer you have got, that factors you multiply, and if you become able to get the question, then your answer is correct. Otherwise it's not correct. You can revise, and where is your mistake you can find out and you can do it correctly. Okay, now factorization of the trinomial of type x square plus minus bx plus minus c. Okay, what is the product of x plus a times x plus b? Okay, here is one example. So after multiplying this x plus a and x plus b, we will get the trinomial of this type. Here x plus a times x plus b, when you multiply this, our multiplication process is that this x will multiply this x plus b, x will multiply x plus b. Similarly, this a also multiplies x plus b. Okay, so each term multiplies these each terms of the second factor. So x multiplies x plus b, a multiplies x plus b. So now x times x is x square, x times b is xb, a times x is ax, a times b is ab. It is the required product, which can be written as, here x square is same from xb and ax. X is common, so x is common. After you take out x, b remains here, and after you take out x from here, a remains here. Here b plus a or a plus b, same thing, so I have written here a plus b, and at last ab. Okay, and this you can express in the form of x square plus, in a plus b, it is constant or number, so that can be represented by another number p, and is x plus ab, product of a and b, also another number that can be represented by q. So this became x square plus px plus q. Okay, so this is same like this. In place of a we have here 1, in place of b we have here p, in place of c we have here q, and then here in both there is plus sign. Okay, hence we conclude that the factors of x square plus px plus q, okay, that they are x plus a times x plus b. Okay, so when we factorize trinomial of this type, and we will get the factors of this type, x plus a and x plus b type, where a plus b, okay, some of these constants, some of these numbers a and b will give you this number, okay, coefficient of x, and when you multiply these two numbers a and b, these are numbers, then you will get this last constant. Okay, now one example, find the value of a and b when a plus b equal to 7 and a b equals to 12. So in this we will factorize 12. So first of all, we will factorize 12. Here 2 can divide 12, 2 6 12, again 2 can divide. Yes, here again 2 can divide 6, 2 3 2 3 6, and from the factors of 12 we will take 82 factors whose sum will be 7. Okay, so here it's 2 times 2, 2 times 2 4, and 4 and 3. While multiplying, definitely it will be 12, and while adding this 4 and 3 we will get 7. So the value of A and B are 4 and 3, or 3 and 4. Okay, and here the factors of 12 are 1 2 3 4 6 12. Checking the values using factors. A equals to 3, A plus B equal to 7. We have B will be 7 is 3 4, then A plus B will be 7. We satisfy both the conditions, hence A equal to 3 and B equals to 4. Okay, or A equals to 4 and B equals to 3 also we can write. So in this way we can find out value of A and B. Find the value of A and B when A plus B equals to -1 and A B equals to -6. So in this here we can factorize 6, and from the factors of 6 we will try to get -1. Okay, so like before, adding 3 and 2 we do not get -1, so we need subtraction. Okay, so here if A value is 2 and B value is -3, then it will be 2 minus 3 will be 2 and minus 3 will be 2 and minus 3 gives us -1. So value of A 2 and B -1 we can take, and when you multiply 2 and -3 we will get -6 as well. 2 times -3 we can get -6 as well. In this way our required values of A and B 2 and -3. Here the factors of 6 are 1 2 3 6. Checking the factors using the factors, and A plus B equal to -1, B equals to -1 minus A. When A equals to 2, then B will be -1 minus 2, that will be -3. Okay, so just by observation or like this process we can get the value of B -3. Hence A equals to 2 and B equals to -3. So now I have kept some classwork also here. Okay, so you can pause the video and you can try this, whether you can do it or not. And for this also checking process is quite easy. Okay, so while adding, if you get 3, and while multiplying value of A and B, if you get 2, then your answer are correct. Here also while subtracting this A and B, if you get -5, and while multiplying value of A and B, if you get -24, then your answers are correct. In this way you can check this easily. Now another example of factorization. So in this type of factorization, here it is perfect square, but last term is not perfect square, so we can't use A square plus 2AB plus B square formula here, because we can this last one is not perfect square. So we have to use another process here. So here we can factorize 18. Okay, we can factorize 18. So 18 factorization, let us do it is factorization. So 2 can divide, 2 9s 18, again 2 9s 18, and again 3 can divide, 3 3s 9, and here 2 3s 6, and then here is 3. 6 plus 3 it will be 9, and 6 3s are 18 as well. So in this, while adding we should get this 9, and while multiplying we should get 18. Okay, so while adding this any two number we must get 9, and while multiplying two numbers we should get same as 18. Here 18 times, here is nothing, this 1, so product of this 1 and 18 is 18. So while multiplying we should get the same number as the product of this 1 times 1 and 18. While adding we must get 9, while multiplying same as the product of this 1 and 18 we should get. Okay, so here 3 plus 6, while adding 3 and 6 we get 9. 3 times 6 18, and here is nothing, means 1 times this 18 is also 18. So product of the middle two, product of this middle two is same as the product of first and last. Okay, so in that way we have to break down this middle part. Okay, main thing is here, so you have to care in that thing mainly. Okay, so here 3x times this product of the sum of the middle two, 3x plus 6x, 3x plus 6x, adding middle two terms we will get 9x, and product of the middle two, that is 3x times 3x multiplied by 6x, 3 6 18, and x times x is x square. Okay, so when we multiply this middle two we will get same result as the first times last. So multiplying first and last, x square times 18 is also 18x square, x square times 18. Also we will get, multiplying this is also we get the same result, that is we will get 18x square. Okay, multiplying first and last and multiplying middle two will get same result. So in place of 9x we can write like this. Okay, so this thing we have to check. Okay, so now from first two, so from x square and x is common. I have already said that smaller power comes out as common. From 6x and 18x there is no x, so 6 will be common. So while taking out we have to take out the HCF of 6 and 18. HCF of 6 and 18 we can find out by using calculator also. So you can see my calculator series video how to find out LCM and HCF, and from that you can find out HCF of 6 and 18 using calculator as well. Okay, and now from this 2 x is common, x plus 3, and from this 2 6 is common, x plus 6 times 3 is 18, 6 is 18, so 3 is here, 6 can divide 18 3 times. So now from this x plus 3 and x plus 3 will be common, and our remaining factor is x plus 6. In this way we have got its factor as x plus 3 times x plus 6. Now another trinomials. So this another type of trinomial is also same type, but here is plus and here is minus sign. So in this to get minus 9 while adding and while multiplying 18x square, how much we should take? We can take minus 3x and minus 6x, so that while adding it will be minus 9x, and product of minus 3x and minus 6x is 18x square. So x square minus 3x minus 6x plus 18. Here while adding minus 3x and minus 6x we will get minus 9x, and product of first and last 18x square, product of middle two is minus 9x. Okay, so that condition is satisfied here as well. And now from this first two x is common like before, and from this last two minus 6 is common, so here x minus times plus is minus, here is 3, So x minus 3 times we have x minus 6. These are our required factors. Okay. Now next expression, here x square plus 3x minus 18.